So hello and welcome to one more video tutorial from Kendrika Academy. Myself Shashwat, educator, and in this video we'll talk about mismatch repair system. What is mismatch repair system? During the replication, you can find that there is a mis-incorporation of a particular nucleotide in your newly synthesized your daughter DNA. So this incorporation of newly mis-incorporation of nucleotide should be removed from the particular DNA because this is causing mismatch. So to perform this repair, to remove this error, the repair system, okay, your DNA is known as your mismatch repair system, okay, which can perform and which can remove this particular type of lesion in your DNA. So this occur when the when your DNA, okay, that is it found a difficulty, or you say that if error occurs during the proofreading of your DNA polymerase, because you know the DNA polymerase is a particular activity of proofreading. Means proofreading, it will move in the back direction, means 5' to 3' direction, and it is found a particular lesion, particular mismatch, particular misincorporated DNA misincorporated nucleotide, and it will remove the particular nucleotide. So when there is a error on the proofreading activity, means already proofread but still it fails to remove that particular nucleotide, that time the mismatch repair system will active and they will have to remove the particular misincorporated nucleotide. So here the mismatch repair system will face mainly two challenges. First is that they have to scan the genome very fastly, very rapidly, to find the mismatch, to find a particular mismatch there first. So they have to scan very fast because they have to finish this repair system before the full length DNA got replicated. Okay, immediately they have to perform this one. So remember this one, this mismatch repair system will occurs during DNA replication. Already is one question came in CSR before year some 2017 something. Okay, then you'll find that in part B question came, they may mention which repair system is occurred during DNA replication. Okay, so during replication DNA mismatch repair system. After that, different types of repair systems are there. They will repair after DNA replication, but during the DNA replication only your mismatch repair system will occur. Okay, then second is that it must replace the misincorporated nucleotide from the newly synthesized DNA, not from the parental DNA. Means it has to recognize between your parental and newly synthesized DNA. So these two are a very challenging activity for mismatch repair system. So how this repair system? First question is how the repair system you recognize between your DNA, between two DNA, parental DNA and newly synthesized DNA, and how it is removing the misincorporated nucleotide. So we'll focus that part. So here we'll see how it is recognized between your parental strand and your daughter strand. So in E. coli, what happened? The parental strand were methylated by a DAM methylase at a residue 5' to 3' GATC sequence in adenosine residue. Means did your all DNA in the DNA there the GATC sequence is there. GATC sequence in the 5' to 3'. So in this GATC sequence, all A are methylated by DAM methylase. Okay, normal strand. Okay, every after replication, all the two strand will be methylated by DAM methylase at your adenosine residue at 5' GATC 3' sequence at adenosine. Clear? So during replication, what happened? This is your parental strand. It is CS3 is there, GATC sequence. Okay. So but the new synthesized strand, it is now replicating on the process of replication is not over. Replication is not over. So in this case, the dimethylase won't methylate adenosine. After replication over, then only it will add a methyl residue to the adenosine residue at 5' GATC sequence. So that's why this repair system have to finish this, okay, this repair before your replication get over. So all GATC is methylated in a parental strand, but in daughter strand GATC is not methylated. So in a particular position we'll get a hemi-methylated DNA strand, means one strand is methylated, another is unmethylated. Means unmethylated is your daughter strand. So now the reference system can easily find out that this strand methylated, means it is your what? It is your parental strand. Which is not methylated, it is your daughter strand. Then see how it will work. So there are some protein like mutase, okay, then mut-L and mut-H. These are main protein in your this process. Okay, mismatch repair proteins. So first what happened, mut-S will come first, mut-S. Okay, mut-S its role is that it has to scan the DNA, okay, to find out the proper mismatch, where the mismatch is there. If there is a mismatch is there, means there is a lesion in the DNA. Clear? So this lesion, okay, you can see here this lesion, okay, in this case you can see there ch3 here GATC sequence. Okay, so this mutase will search the DNA to find out the lesion. It find, then it will bind to the particular lesion, then it will recruit mut-L. Okay, it will first it will bind to lesion, then it recruit mut-L. Both now they come. Okay, mutase mut-L, they form a complex. Then what happens, they'll pull the DNA from the two side. Okay, on the both sides they'll pull this DNA. See here you can see this is the mutase mut-L complex. They pull the DNA, so here there is a formation of a loop. Okay, then what happened, when they'll pull the first GATC sequence, when it will come, then they stop this pulling, because in the GATC sequence the CH3 is there, so they found the CH3 and their mutage is also reside in the near the GATC sequence. Clear? Mutage is to be in the GATC sequence. So mut-H is one more enzyme, okay, which helps in this process. So mutase role is to cut the particular DNA in your newly synthesized strand. So when they'll pull, when the first GHC sequence, first CH3 or first mut-H will come, this they stop the pulling and the mut-H become activated and it cut the 3' your newly synthesized strand. You can see it cut the newly synthesized strand. Then this nick can be removed, this part, by UVRD. It's a specific helicase. It will remove this particular DNA, okay, from here till this part, and this can be repaired. Once more it can be filled by your DNA polymerase 3. Clear? In E. coli, that's why we're talking about E. coli. So it's DNA polymerase 3. So this remember, this mutate is inactivate when it is near the GATC methylated GATC sequence, but when it come to the mut-L mutase complex, come in contact with the mutase complex, then only it become activated and it will cut. Okay, so but here you can see that this part you can see here. Okay, so you can see here, if this CH3 and CH3, this is 5' and this is 3' and is caught is there in 5' side, and this, if it is caught in here, it will be 3' side. So which helicase will you see here? UR did come, I just said this one like that, but specific helicase we require to remove this DNA. Okay, so different exonucleases have different activity. Some exonucleases they can cut from 3' to 5' direction, some from 5' to 3' direction. So we have to choose like that. Okay, so how this happen, we'll see now. So as you see here, your mut-L complex and mutase complex, they already cut the DNA. Okay, after cut, here you can see there is a cut in your 5' side, here they cut in your 3' side. Okay, so here what happened, now different type of exonucleases are there. If the cut in your 5' side, this have to remove this part, means 5' to 3' exonuclease we need. So the exonuclease is your exonuclease VII. If there is a cut in your 3' and this part of DNA is removed by 3' to 5' exonuclease, this exonuclease may be your exonuclease 1 or exonuclease 10. Okay, it remove by the exonuclease, then DNA and to remove, okay, it will digested and caught by your exonuclease. Then your DNA polymerase 3 with single stranded binding protein once more will synthesize your DNA. Okay, it will form your newly proper mis-incorporated DNA or your proper DNA. So clear. So remember this part, that one part is that your GATC, your A will be methylated. Next to this repair system will occur during, okay, during replication, okay, and the main part your exonuclease, which exonuclease read 7 is from 5 to 3 prime, exonuclease 10 from 3 prime to 5 prime, and role of mutase, mutal. This is enough for your mismatch repair. Clear everyone? So thank you everyone and have a good day. For more updates you can go to our Kendrika Academy site. Okay, then thank you everyone.